All right. Now we move on to 7.4, where we try to talk about how to solve equations which involve trig values. We start from the very basic. Solve for the equation. Okay. Sin x equals 1/2. So this will be the basic. Okay. So how do we solve it? Number one, a very straightforward way to sine inverse 1/2. You got the answer. But then you realize, well, how many angles are there will give you 1/2? Infinitely many, because if you find one, if you plus another integer multiple of 2 pi, it will still work. But if you just simply do the sine inverse, it only gives you 1. Okay, so that's going to be hard, not complete. Okay, so what we should do is, number one, because sin x and 1/2, we know it's definitely going to be related to pi over 6 by looking at the 1/2. I know it's related to pi over 6. And after that, I should really think about all the possibilities. Well, who gives you 1/2? Or who is related to pi over 6? That's going to be this one, this one, this one, and this one. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. They all give me something related to 1/2 if I take sine. Good. So they're all possible. Second, we do know for sine, it's positive 1/2 here, positive 1/2 here, negative 1/2 here, and negative 1/2 here. Therefore, these two should be excluded because of the sign. You are looking for positive here, since I write down 1/2. The negative 1/2, even though it's related to pi over 6, they should not be included. These two are the only possibilities. Therefore, you should write down your x should equals pi over 6, or your x can equals 5 pi over 6 in order to give you 1/2. Okay, good. Finally, you should plus 2n pi and 2n pi, because if pi over 6 is okay, then pi over 6 plus another complete cycle of 2 pi, which come back to the same terminal angle, is also going to be okay. And if you keep adding 2 pi, keep adding 2 pi, keep adding 2 pi, they all qualify. Similarly, if you keep minus 2 pi, they also qualify. Therefore, your final answer should be this one here, where n can be any integer, positive, negative, or 0. That will be the most inclusive answer, including all the possibilities of solving sin x equals to a particular value. Okay, judging by the graph, it's the same logic, but a different approach. This is your sin x. Okay, and you're wondering where sin x equals 1/2. So this is 1, negative 1, and this is 1/2. So what you're asking is, where does this graph intersect with 1/2? Well, certainly here and here. But if it's here and here after 2 pi, here and here will work, here, and just keep going. That's why you need to plus 2n pi, because this point, and this point, and this point, if one of them qualify, all of them qualify. Similarly, if this qualify, then this qualify, then this qualify, and this qualify. That's why we plus 2k pi. And clearly, we have two answers within one cycle, unless you're here. You only have one answer. Meanwhile, we have two answers which have the same value, but in the opposite sign. That is these two. But then, after some investigation, we excluded them because they are negative, even though they definitely give us 1/2. Okay. But that's negative 1/2. All right, so that's what we have. Now to make it clear, I want to talk about the procedure. So next time you see sin x equals to some number, for example, or maybe cosine x equal to some number, Let's do an example. Solve for x. Okay. And I will decompose it into the following procedure. Number 1, do cosine inverse 1/3. For that case, for 1/2, we can get a special angle. But for this case, we cannot have a special angle. So just keep it that way. Okay. Ignore the negative. Okay, no matter it's positive or negative, always do the positive one. The good news about this is, once you do that, you will always have some angle in quadrant 1. You don't have to worry about it if it's positive or negative. But once you have this one, you have all these. You will always have 4 answers, except for the 1 and -1 case. Now the next thing is, give each answer a sign. It's depending on what you have here. For here, you have cosine, therefore positive, positive, negative, negative. So you deal with the value first, but then you deal with the negative sign. That will help you to exclude this one, exclude this one, and giving you only this and that. That's step 2. Handle the sign. Step 1, ignore the sign. So you always have something in quadrant 1, and based on that, you have all the 4 of them. So from here, you can see what we're trying to do here is try to find the reference angle or reference number. Okay. Now, second, now you start to worry about negative. For negative, it just helps you to pick the quadrant. And usually, most of the case, you have 2 answers. Number 3, calculate the 2 answers using the angle you had before. How big is this angle? It's not an easy angle. It's called cosine inverse 1/3. Then this is cosine inverse 1/3. Therefore, the first angle is going to be pi minus cosine inverse 1/3. And the second angle is going to be pi plus cosine inverse 1/3. And we don't know what cosine inverse 1/3 is unless we have a calculator. So we have 2 answers. The one in quadrant 2, the one in quadrant 3. Okay. Now the 4th step, which I will just put here, that is add the 2 and pi. Because a complete cycle doesn't change this cosine value, they should be all included for n. Just n can be any integer. Okay, so if I want to do that, I will say this is step 4, add 2 and pi. Because your sine function is periodic. If one works, add another complete cycle, it also works. Okay, let's try one more, this time really quickly. Let's try cosecant x equals -3 or -4. Okay, like we said, we never handle cosecant. When you see that, it's the same as solving sine x equals -1/4. All right, now step 1, sine inverse 1/4. Ignore the negative. Therefore, possible, possible, possible. Okay. Step 2, draw the sign. So positive, positive, negative, negative. And because you have negative, we take these 2. Number 3, write down the angle. It's going to be pi plus sine inverse 1/4. And the next one is going to be the one in quadrant 4, which is 2 pi minus sine inverse 1/4. Plus 2 and pi, plus 2 and pi. N can be any integer. Okay, value first, use the sign to handle the quadrant next. Finally, write down the angles and plus 2n pi. That's how we solve it. Okay? Side note, how do you solve this? Tangent theta equals 1/2. If you use the same logic, you can have therefore we should take this one and this one. Okay. X plus pi. Okay, which is the one in the third quadrant. And can be. Now, you can check by yourself. This answer is correct, number 1. But we do have a more efficient way to write them, that is where you change the 2n pi to be n pi. So within one cycle, you do have two values. And the relationship between them is one is the other one plus a pi. So there is a more efficient way to write down the answers for tangent. It would be nice if you could write things in this way. But if you write things in this way, they are totally correct. Okay, so I will give you credit for both. Either way you write down the answer in the exams, I will give you the full credit. But the one on the bottom is better because number 1 is shorter. Number 2, it reflects the fact that is the period of tangent is pi, not 2 pi. Not 2 pi. Okay, but if you do the 2 pi, you simply just list the two individual angles, which is also fine. Okay, so that will be the basic. Now the second one, solve the trig function on a given interval. So we'll make a little bit more requirement. Okay, that is try to solve sine x equals to 1/2. Let's do negative 1/2. Let's do cosine. Example. But this time you only want the solutions on 0 to 3 pi. So the difference with before is you have one additional restriction, that is you only want everything from 0 to 3 pi. Judging by the graph, it's very easy to see. You know if you have cosine. We haven't solved it yet, but we know we are going to have infinite many answers. The reason is because you have this, you have this, you have this, you have this, and you have this, and you have this. You just keep going. But then we put a restriction. That is, we only care about the answers going all the way from 0 to, this is 2 pi to 3 pi. So we only care about the solutions between 0 and 3 pi. Therefore, we only care about these three answers. I just wonder what they are. We don't care about the ones beyond this interval. Okay. So how do we solve this? And the answer is quite easy. Number 1, solve this. Pretend you didn't see the interval. And you will have the answer. That will be the whole collection. And number 2, you go into the collection, check each one of them, and see which ones belongs to 0 to 3 pi, and write them down. So, what do we have? Forget about the interval. Solve this one first. We have x equals pi over 3 cosine. Therefore, we should need these two. X equals 2 pi over 3, or x equals 4 pi over 3. N can be any integer. That's step 1. Step 2, we take the solution from the previous one. Now we try to check which ones are in the 0 to 3 pi. So what do? We start from here. We plug in different n. N equal to 0. We have 2 pi over 3, qualify. N equals 1. 2 pi over 3 plus 2 pi, which is is it between 0 and 3 pi? Yes. N equals 2. 2 pi over 3 plus 4 pi, another 2 pi. Certainly it's bigger than 3 pi, therefore it's not qualified. Once this one is too big, anything after that will also be too big because you keep adding 2 pi. So only these two qualify if you go this direction. Of course, you can go the other direction. That is n equals -1. Less than 0. You want something between 0 and 3 pi, so this one is already not qualified. So when you go to the direction in the smaller side, you stop at 0. When you go to the direction in the positive side, you stop at 1. This will be the only choices. Anything beyond that is either too small or too big. Okay. Now you just need to repeat the same thing for the next selection. You have another one. That is 4 pi over 3. Okay, n equals 0. 4 pi over 3, qualify. N equals 1. 4 pi over 3 is bigger than pi. 2 plus another 2 pi is bigger than 3 pi. Done. Done. So only this one is qualified. According to what we just said, we have 3 possible answers out of the infinite many collections which belongs to between 0 and 3 pi. Judging by the graph we draw here, because we draw it really accurately, we do only have 3 options. Now we know who they are. So from here you can see once you are asked to solve trigonometric values within a certain interval, the first thing you need to do is actually pretend you didn't see the interval and repeat what you had before. After that, the interval is only used for you to select out of the infinite collections that who belongs to the solution and who does not. So I think it's pretty clear of the procedure. You go ahead and try yourself. Okay? But from now on, our energy will be focused on how to solve the equation without the interval. And with the interval, it's just some minor additional work. All right. So we solved the very basic trigonometric equations. Now we want to combine the trigonometric equations with other equations we know. And the right way to think about this is you treat them differently. You solve the other equation until you have a trig equation, and then you solve the trig equation from there. Okay? Let me show you what I mean there. First one. Is this a trigonometric equation? Well, technically no, because for trigonometric equation, we only solve a trig value equals some number. It's not a trig equation yet. So what you want to do is probably ignore the trig part. Instead of solve for x, solve for tangent x. After you solve for tangent x, solve for x. Okay? So if you ignore tangent x, you can just let tangent x equals a. Then what you have here is nothing but a squared minus 3 equals 0. So what are you trying to solve? You are not trying to solve a trigonometric function. You are trying to solve a quadratic function. Of course you know how to do it. That's step 1. You already know tangent x equals what. But after that, You can write it out. And this time, you have the exact basic trig equation to solve because it's tangent x equals to a number. Okay, for this one, what are you trying to do? You're trying to take the tangent inverse, which gives you pi over 3. For this one, you are trying to do the same thing. Okay, for tangent, positive, positive, negative, negative. So for positive square root of 3, you should take these two. For the second case, you should take these two. Now putting these two together, you know, actually you should take the 4, the whole 4. So the final answer is x equals pi over 3 plus n pi. And this is x equals 2 pi over 3 plus n pi. And the answer is actually merging them together. So n can be any integer. So I did a change of variable. After you change the variable, you can actually ignore the trig function for a while until you finish the first part, and then you focus your energy on the trig function alone, trig equation alone for the second part. You don't have to define a variable every single time. Okay, I'm just doing this for you to see it clearly. Okay, let's try another example. Again, you don't have to, but if you get confused, at first I would recommend to change the variable. But because once you do that, you get rid of the distraction from the trig values and focus on what's outside the trig value. And then you realize this is a quadratic. So you can solve the same thing, the whole thing without even worrying about the trig values. Once you finish that, it's the time you review the second layer. But when you do this, you don't have to worry about the square or anything before because it's already solved. You just worry about the trig value. Okay? For which value, if you plug in, you got 3. Or what is the value of sine inverse 3? Not possible. Okay. What's the value of sine inverse -1? Only one choice. This is the only case when you only have one answer. Every other cases, you have 2 answers. So that is going to be happening here. At the extreme value of 1 and -1, you only have one answer. All right. Okay. You can go ahead and factor it out directly. If you think this structure is clear to you and you don't get confused, it's actually recommended. But if you think this is hard for you to see the structure at the beginning, do the change of variable to help yourself a little bit. Once you see the structure, I think it's pretty straightforward. Okay. One more example. How do you solve it? If you are familiar with what we have done before, this time we try to not to reassign a variable, but do it directly. Then you see the old algebra still works. So 2 things multiply equals to 0. What are the possibilities? The possibilities are cosine x equal to 0 or secant x minus 1 equal to 0. Okay. This one gives you two possible branch, secant x equals 1, or secant x equals -1. So together, if you include all the three cases, we have case 1, cosine x equals 0. Case 2, secant x equals 1, which means cosine x equals 1. Case 3, secant x equals -1, and if you flip it, that means cosine x equals -1. Now we just need to solve each and finally put the answers together. Cosine x equal to 0, here and here. Cosine x equals 1, here. Cosine x equals -1 here. Now if you put them together, it's very clear to see. It's basically the four x-axis. So you have all kinds of ways to write them down. I think the best way to write them down is zero plus a multiple of pi over 2. You do it for once, you are here. Do it for twice, you are here. Do it for 3 times, you are here. Do it for 4 times, you complete the whole cycle. And just keep repeating. Okay. So the final answer is just this. If this is hard for you, you can also say it's 0 plus 2n pi, or pi over 2 plus 2n pi, or pi plus 2n pi, and you can write them down into 4 different answers. They're all correct. It's just this way is the best because it's easier. Okay, that's all we have. That's all we have for basic trig equations. Next time we will solve something involving a more complicated setups, but the spirit is the same. Moreover, if somehow I give you this equation and say solve it on the interval -pi to 2 pi, what should you do? You should still repeat the whole thing until you reach this answer. And then you start to use the interval by plugging different n's to see which one is qualified and which one is not qualified. Okay, we didn't do much exercise on that because it's really easy to set up.